So this is what a 3D cone looks like. It has a height h, it has a circular base which has a radius of r, then it has a slant top which is covering the circular base. So this part, that is the length L here, which is covering the circular base, is called as the slant height of the cone. So L is equal to the slant height. Now this is called a right circular cone. Well, it is called circular because it has a circular base, therefore circular, and it is right because the angle between the height and the base radius r is equal to 90 degrees. So it is called a right circular cone. Now this is which is not a right circular cone looks like. Because the angle between the height and the base radius is not equal to 90 degrees, therefore this is not a right circular cone. Now there are two conditions that need to be satisfied in order to state that whether a given cone is a right circular cone or not. So the first condition that needs to be satisfied is the line joining vertex to center of base should be a perpendicular line to the base. So this is the vertex and the center of the base is this that I have marked. This is the center of the base. So the line joining, that is the height, is perpendicular to the base. Yes, the angle between them is 90 degrees. So the condition 1 is satisfied. According to condition 2, base of the cone should be circular. So yes, the base of the cone is circular. So these two conditions are satisfied, therefore it is a right circular cone. Now we see that this is a right angled triangle which has a perpendicular edge, which has a base radius, and it has a hypotenuse L. So we can apply Pythagoras theorem to this triangle. So according to that, L square, that is hypotenuse square, is equal to base square plus perpendicular square. So h square plus r square. So what do we conclude is that if we are given any two quantities in the cone, that is either height or the radius, we can automatically find the third quantity. So when we'll be finding the surface area of the cone or the volume of the cone, we'll be maximum needing only two quantities in order to find the asked. So now let us find the surface area of the cone. So this is a 3D cone. It has a circular base and it has a slant height L, which is marked by red. So in order to find the surface area, we'll be opening this cone. So this is what it looks like. The green part of the cone is corresponding to the circumference of the circular base, and these red lines marked are the slant height of the cone, that is corresponding. So this is L, and this is equal to 2 pi r, that is the circumference of the circular base. Now in order to find the surface area of the cone, we'll be dividing this opened part of the cone into many triangles, something like this. And what we'll be doing is we'll be cutting them and putting up them like this. So when we do that, we see that we get a rectangle. This rectangle has length and breadth. So the breadth is equal to L, as it is corresponding to the previous figure, and the length is equal to pi r. Reason being that this is the side L1 and this is the side L2. So L1 plus L2 is 2 pi r. So the one side is pi r. So now in order to find the surface area of the cone, if we find the surface area of this figure, that is the rectangle, we'll be able to find the surface area of the cone. So the surface area of this rectangle will be length into breadth. So the curved surface area of the cone is equal to length into breadth pi r L. Here r is the base radius and L is the slant height of the cone. Now if we add a base to the cone that we have, then it becomes a closed figure. So now we'll be able to find the total surface area of the cone. We'll be adding the area of the circular part that is added. So the total surface area of cone is equal to pi r L plus pi r square, that is the base area. So pi r into r plus L. So now we have got the total surface area of cone. Now in conclude, curved surface area of cone is pi r L and the total surface area of cone is pi r into L plus r. Now let us do one example in order to understand this concept. So the example is, the height of a cone is 16 centimeters and its base radius is 12 centimeters. We need to find the curved surface area and the total surface area of the cone. We need to use pi is equal to 3.14. So it is given that the height of the cone is equal to 16 centimeters and the base radius, that is the radius of the cone, is 12 centimeters. So we need to find the curved surface area of the cone. So we have found out the curved surface area in the previous few slides. So curved surface area of cone is equal to pi r L. So here L is not given. We'll be finding the value of L since we know the two quantities. So when we apply the Pythagoras theorem, so according to that, L square is equal to h square plus r square. Now L square is equal to, the value of height is 16, so 16 square plus 12 square. So 16 square is 256 plus 144, and this is equal to 400. So L is equal to under root of 400, thus it is equal to 20 centimeters. Now we'll be able to put the value of L in the given formula of the curved surface area of cone. So this is equal to pi into 12 into length that we have found out is 20, slant height. Now 3.14 into 12 into 20, that is equal to 753.6 centimeters square. Now we need to find the total surface area of the cone, so we'll be adding the base to it, that is a circular base. So total surface area of the cone is equal to pi r L plus pi r square. So that is equal to, we have found the value of pi r L, that is 753.6 plus 3.14 into radius is 12, that is 144. So this comes out to be 753.6 plus 452.16, and this is equal to 1205.76 centimeters square. So we have the curved surface area of the cone as 753.6 and the total surface area of the cone as 1205.76 centimeters square.